Hi, we're here today to present a topic of torsion series in regards to mechanics of materials. My name is Adam.
And I'm Carly.
And she's first going to go over the formulas that are mainly used in torsion, and then I'm going to go through an example.
Torque is the moment that twists an object. Torque is shown by a double arrow. We use the right-hand rule to determine the direction of the twist. For this example, we point our thumb in the direction of the torque, and we curl our fingers to determine which way the twist will occur. Torque is used to determine the shear stress, and the following formula is used, where tau equals the shear stress, T equals the torque applied, J is the polar moment of inertia, and R is the distance from the center to the point of interest. We use this formula to find J, pi over 2 times R to the fourth. For a pipe, we need to take into consideration both the inner and outer radii, where in this diagram, the blue is the inner radius and the green is the outer. Now, Adam will go through an example with you.
Hi, the example we'll be going through today is how to determine torque when you are given a shear stress and a certain distance for the radius in a solid shaft. Here I have drawn the center cut of a solid shaft where this point here represents the center of the shaft, and we are going to determine the torque needed to apply a shear stress of 5 psi at point A and then again at point B. So the first thing we need to do in order to determine the torque applied at A for a given shear stress of 5 psi is to rearrange the equation that Carly gave in the first part of this video, which is what I did in step 1 here, which I now made it equal to torque equals tau times J over R. Next, we're going to need to find J, since J is the only unknown on the right-hand side of the equation. By plugging in the values given in the diagram here for J, we come up with the amount of 648 pi per inch to the fourth. We then, after finding the value for J, come over to step 3 and plug in the given values along with the value J in order to determine T at point A. After plugging in these values and canceling out the duplicates, we come up with a value of 1,696.46 pounds per inch of torque needed to create a shear stress of 5 psi at point A in the solid shaft. Now, if you wanted to find the torque needed to create a shear stress equal to 5 psi at point B in the shaft, we go through the same exact steps that I've laid out on the board, except now instead of using 6 inches for R, we're going to use 1 foot or 12 inches. After doing the same computations and plugging in the same values for R and tau into the formula, you come up with a number of roughly 13,571.7 pounds per inch of torque needed to create a shear stress of 5 psi in the solid shaft. So as you can see from the example, a much larger torque is needed in order to create the same amount of shear stress in a solid shaft. We will now go over a visual representation of what torque looks like in a given series.
This is an example of 2 torques applied in a series. The yellow torque wants to twist the pipe in this direction, while the blue torque wants to twist in the opposite direction. But since they're of equal magnitude, they cancel each other out, so at the fixed end there's a net torque of 0. If a third and greater torque is applied to the pipe as well, then total net torque is going in this direction, so the reaction at the fixed end has to go the opposite direction to stop it from moving.
This ends our presentation for torsion series in regards to mechanics of material. We hope you enjoyed it, and we hope that you've learned something from our examples.
Thank you.
Have a good day.